As we studied in our previous lecture about finding the unit of equilibrium constant, here we will find the value of equilibrium constant today, and the value of equilibrium constant Kc can be calculated or can be determined if the concentration of reactants and products are known. So we can calculate the value of Kc through the concentration of reactants and products. For example, in this question, in equilibrium mixture, concentration of H2 and I2 is 0.04 mole per decimeter cube each, and while that of the Hi is 0.08 mole per decimeter cube. Find Kc value here. Here in this question, concentration of H2 and I2 are known. Here the concentration of Hi is this one. Here H2 and I2, these are reactants, and Hi is product. First of all, we write data here. Here the concentration of H2 is equal to, concentration of H2 is 0.04 mole per decimeter cube, and concentration of I2 is also, here concentration of I2 is also 0.04 mole per decimeter cube. Here concentration of Hi is 0.08 mole per decimeter cube. First of all, we will write the balanced chemical equation here, which is H2 plus I2. It gives us 2Hi. Here H2 and I2 are reactants, Hi is product, and we have the concentration of H2, I2 and Hi here, and we calculate the value of Kc, equilibrium constant Kc. First of all, we will write data, then we will write balanced chemical equation, then we will write equilibrium constant expression, which is equal to the product of concentration of product to the product of concentration of reactant. Here products are Hi, so here its coefficient is equal to 2, so this 2 can be written in the form of POR to the product of the concentration of reactants. H2 and I2 are reactants here, so we will write reactants as denominator. We will write products as numerator, and we will write reactants as denominator. Now we put the concentration of Hi, H2 and I2 in this equation. We will have concentration of Hi is 0.08 mole per decimeter cube. Concentration of, we takes care of this 0.08 mole per decimeter cube. Concentration of H2 is 0.04 mole per decimeter cube, so we will write here 0.04 mole per decimeter cube. Similarly, concentration of I2 is also 0.04 mole per decimeter cube, so we will write 0.04 mole per decimeter cube here. Here this 0.08 mole per decimeter cube multiply with the 0.08 mole per decimeter cube, or we will take the 0.08 mole per decimeter cube whole square. We have value 0.0064 mole per decimeter cube whole square divided by 0.04 mole per decimeter cube multiply with the 0.04 mole per decimeter cube. We have the value 0.0016 mole per decimeter cube whole square, because this mole per decimeter cube also multiply with this mole per decimeter cube, and we have the unit mole per decimeter cube whole square. This mole per decimeter cube whole square cancel out the mole per decimeter cube whole square in the denominator, and this 0.0064 divided by this 0.0016 we have the value 4. So here Kc has the value 4. So if we have the concentration of reactants and products, then we can calculate the value of Kc. Similarly, in other example, when CO react with H2O, it forms CO2 and H2. Here in this question, concentration of reactants CO and H2O is about 0.0600 mole per decimeter cube. Concentration of H2O is about 0.120 mole per decimeter cube, and concentration of CO2 and H2 is concentration of CO2 is 0.150 mole per decimeter cube. Concentration of H2 is 0.300 mole per decimeter cube. So here we have the concentration of reactants and products. Here we will calculate the value of Kc, or equilibrium constant. First of all, we will write data here. Here we have the concentration of CO, which is equal to 0.0600 mole per decimeter cube, and concentration of H2O is equal to 0.120 mole per decimeter cube. Here concentration of CO2 is about 0.150 mole per decimeter cube. Similarly, concentration of H2 is 0.300 mole per decimeter cube. Here we will calculate the value of Kc. So first of all, we will write the balanced chemical equation here, which is CO plus H2O. It gives us CO2 plus H2. Now we will write equilibrium constant expression, which is Kc is equal to product of the concentration of product to the product of concentration of reactants. Here products are CO2 and H2, so we will write the product of the concentration of product, which is CO2 and H2O, to the product of the concentration of reactants, which are CO and H2O here, because here these are products, CO2 and H2 are products, and CO and H2O are reactants. So we will write products as nominator and reactants as denominator. Now we put the values of these products and reactants in this equation. So we will write a concentration of CO2, which is 0.150 mole per decimeter cube, multiply concentration of H2 is about 0.300 mole per decimeter cube, divided by the concentration of CO, which is here 0.0600 mole per decimeter cube. Similarly, concentration of H2O is 0.120 mole per decimeter cube. Now we multiply 0.150 into 0.300, so we have the value 0.045 mole per decimeter cube whole square, divided by this 0.06660 multiply with the 0.120, so we have the value 0.0072 mole per decimeter cube whole square. Now this mole per decimeter cube whole square cancel out the mole per decimeter cube whole square, and then we divide the 0.045 to the 0.0072, we have value 6.25. Here Kc has value 6.25 and Kc has no unit because units cancel each other. So here we also calculate the value of Kc when we have the concentration of reactants and products in this question.